Okay, children, we are moving on now. Now, this is the general definition of a polynomial. So what this definition says is any expression of the form p of x with a0 plus a1x plus a2x to so on till an, where the powers of the variable are non-negative integers and coefficients are real numbers, is called a polynomial. Is called a polynomial in the x of nth degree over real numbers. Children, please observe the board. Please observe the board here. I want to explain something here. So, for suppose I have an algebraic expression like this. Can I call this as a polynomial? Please type in a yes or no. Type in a yes or no, please. Can I call this as a polynomial? No. Priscilla, good. No. Great. So, Priscilla, can you unmute yourself and say why it is a no? Why I cannot call this as a polynomial?
So because in your expression, one of the x has a minus 2 power, and the polynomial definition says that you're not supposed to have a negative integer power. So that's why it's not a polynomial.
Very good, very good, very good. Very good, Priscilla. So that means what? Whenever I see, even if I have the other powers as whole numbers, but still if one of the powers is negative, I cannot call this as a polynomial. Now what about this? What about this, please? Please type in yes or no. So Priscilla, you're asking me, that means you're in doubt, is it? Anybody else who can try? Can I call this as a polynomial? I will get back to all of you, but I want you guys to try.
Sir, I meant that like I say no, but I'm not really sure.
Okay. Sayed says it is yes. Okay. Arna and Unmana, any answers?
Can you repeat the question?
The question is, can I call this as a polynomial? The second algebraic expression, can I call this as a polynomial? No idea. Okay, it's okay. Okay, children, I cannot call this as a polynomial because one of the power is having a root. Root means what? The power is x equal to half. Whenever I am having a variable with power half, I cannot call this because in the definition it says the power of the variable should be a whole number or a non-negative number, non-negative integer. It should be a whole number, but here I have half. Half is not an integer. It's not a non-negative integer. It's a fraction. That's the reason I cannot call it as a polynomial. Are we okay, children? Type in a yes, please. Are we okay with this understanding that these examples are not polynomials? Are we clear with the definition of polynomials? Please type in a yes.
So not totally.
Okay. So what I'm trying to tell you is, if I have the powers of the variable as a negative or as a fraction, I cannot call them as a polynomial. Whereas if I have something like this, I have x power 5. plus x cube plus x power 0 plus 1. Now I can call this as an operator 1 here. Can I call it as a polynomial now? Those who want to answer can unmute yourself and answer please. Can I call it as a polynomial? No. No.
Sir, I take back my answer.
Can I call it as a polynomial, Priscilla?
Yes.
Yes. Guys, you can call this as a polynomial because the power of the variable is a whole number here. It is non-negative. In this case, in the first case, what was happening is the power was limited. Here it was fraction. But I can have the power of the variable as a whole number or a non-negative integer. This can be written as x power 5 plus x cube plus 1. X power 0 is nothing but 1.
And the exponent is 0. So, okay, it's a whole number.
Yeah. The power should be a whole number. Children, are we clear? So I can call this as a polynomial. These two I cannot call them as a polynomial. Although all of them are algebraic expressions. I hope I'm clear here. Yes? Okay.
Yes.
Yeah. Thank you. We're moving on now. Children, have you noted down the examples? Please note down the examples. Okay. Let us understand what is the general form of a polynomial. So general form is whenever I have a polynomial, I should write the highest powers first. For suppose I have f of x is equal to x power 5 plus x cube plus x plus 1. So whenever I have a polynomial, I should always write the highest power first. That means the powers are in the descending order here. So whenever I am writing a polynomial, I need to keep this in my mind that I should write always in the descending order of the powers. This is nothing but the standard form of a polynomial. Okay, children? So, now, here, if I ask you what is the degree of this polynomial, here if I ask you what is the degree of this polynomial, can you please type in the chat box what is the degree of this polynomial? Type in the chat box please, what is the degree of this polynomial? Whatever you know about the degree of a polynomial.
The degree or the highest degree?
Degree of a polynomial. Just type in the degree please. Nobody? 8. Okay. Any other answers? Any other answers? Kunmana, no answer. Nobody else apart from Priscilla? Here, the degree of this polynomial is 5. Degree is 5 because this is the highest power of the variable in this polynomial. The highest power of a variable in the polynomial is its degree. Okay. Okay, children. And the degree should always be a whole number. It should always be a whole number. It cannot be a negative integer. It should always be a number. Okay? Degree is nothing but the highest power of the variable. One variable that we are having here, x is the variable, correct? Here the variable is x. Here the variable is x. I will say the degree is 5. Degree is 5 because that is the highest power of the variable in this polynomial. Children, I hope I'm clear with the definition of the degree. Okay. Degree is nothing but the highest power of the variable in the given polynomial. Does everybody agree with me that this is a polynomial? Yes, it is a polynomial, right? And now I am having the highest power of the variable as 5. Here the variable is x. Its highest power is 5. Therefore, my degree in this case is 5. Children, please type in a yes if you have understood what is the degree. Please type in a yes. Okay. Syed, please type in a yes if you have understood. Okay.